In this video, we're going to be doing lesson 5.7, which is on imaginary numbers. So you're going to learn what an imaginary number is and how to work with those. So if we think back to the last lesson, you saw equations like this. And most likely you would say, okay, subtract 1 from both sides and then take the square root, which is correct. However, you don't take the square root of a negative number. If you think about it, there's nothing that you can multiply by itself to get a negative number, because square rooting is the opposite of squaring. Like 2 times 2 is 4, square root of 4 was 2. Okay, well, what about negative numbers? Negative 1 times negative 1 is positive 1. So there's nothing that you multiply by itself to get negatives, and therefore you can't really take the square root of negative numbers. So that's where imaginary numbers come in. So you need to know, just have it memorized, that I is the square root of negative 1. Kind of like pi is 3.4159 and so on. I is the square root of negative 1. And I squared is negative 1. You need to have those memorized. And so let's start with simplifying negative square roots. So we're going to kind of do this like we did simplifying regular radicals, but there's negatives involved. So there's an extra step. So for example, when I see the square root of negative 9, it is not negative 3. It's not negative 3. What we do is we're going to take out the negative 1. Like I'm going to divide out the negative 1, and that leaves me with a positive 9. Okay? And we know, because I just told you, that the square root of negative 1 is what? You just wrote it down. The square root of negative 1 is I. And what is the square root of 9? Positive 9 is 3. And so we're left, this is being multiplied, with I times 3, which is 3I. Just like with variables, regular variables, you put the number in the front. So the square root of negative 9 is 3I. Okay, so number 2, we have a negative number under the square root. So the first thing we're going to do is pull out that negative 1, and that leaves us with positive 196. I know that the square root of negative 1 is what? I. And the square root of 196 is 14. 196 is a perfect square. So when I put those together, we have 14I. Number 3, square root of negative 5. I'm going to take out the negative, and when I divide that by negative 1, it leaves me with positive 5. The square root of negative 1 is what? I. And square root of 5. Well, 5 is not a perfect square, And if I think about all the perfect squares, there's actually nothing that goes into 5. So square root of 5 cannot be broken down anymore. Now when we have a radical, that always goes at the end. So the way I write this one is I square root of 5. So if you have a number, that always goes first, then your I, and then your radical. Or if you have any combination of those, your number would always be in the front, then your I, then your radical. All right, number 4, we have the square root of negative 80. So because I have the square root of a negative, I have to pull out that negative 1 first, and then that leaves me with 80. Is 80 a perfect square? It is not a perfect square, but there are perfect squares that go into 80. So take your calculator and figure out what the largest perfect square is that goes into 80. So start with some of your perfect squares. Maybe try 36, I don't know. Go through your perfect squares and find the biggest one that goes into 80. So 80 divided by, you could even start with 49. 80 divided by 36. 80 divided by 25. 80 divided by 16. And you'll find that 80 divided by 16 is 5. So 16 is the biggest perfect square that goes into 80. So I just brought down my negative 1 and then I split up the 80. We know the square root of negative 1 is I. The square root of 16 is 4. And then the square root of 5 does not break down at all. So when I put these all together, my 4 is going to go first, then the I, then the radical 5. Any just plain whole numbers go in the front, then your I, then your radical. All right, number 5. We have the square root of negative 32. So because we have the square root of a negative, I'm going to take out the negative 1 first, and that leaves me with a positive 32. Okay, so the negative 1, I'm just going to bring that down. What is the largest perfect square that goes into 32? It's going to be 16, because 16 times 2 is 32. Well, what is the square root of negative 1? We know that's I. What is the square root of 16? 4. And square root of 2 doesn't break down anymore. So my final answer is 4i radical 2. All right, try number 6 on your own. All right, so number 6, we were breaking down the square root of negative 192. Oops. So because it is a negative, because there's a negative number under the square root, we take out the negative 1 first, leaving us with a positive 192. And then we have to figure out what perfect square goes into 192. You should have already worked this one out. You should have already found that it was 64. And then this became I, the 64 became 8, and then the square root of 3 stayed. So 8I radical 3. All right, so this then goes into solving equations. This is very, very similar to what you've done before in the last lessons when you've solved, except now the radicals have negatives. That's the only difference. So if we have something like x squared plus 81 equals 0, when there's no plain x, you can solve like a normal equation. You don't have to factor, don't have to do any extra stuff. So we're going to start by subtracting 81 from both sides. And we get x squared equals negative 81. And then we know, well, we take the square root of both sides. But the square root of 80 or negative 81 is not negative 9. Remember, we take out the negative 1. And that becomes I, and the square root of positive 81 is 9. So x equals 9I. When we're solving equations this way, remember you have to put the plus or minus. So x equals plus or minus 9I. Number 8, first step is to subtract 9 from both sides, leaving us with 2x squared equals negative 8. And then we divide both sides by 2. X squared equals negative 4. And then we take the square root. It's not negative 2. Now, if it's you may catch on to these enough to not need to write this extra step. But if you do write that extra step, that's okay. Square root of negative 1 is I. Square root of 4 is 2. So x equals plus or minus 2I. Okay. Number 9. We subtract 15 from both sides. And we get 4x squared equals negative 24. And then we divide by 4. And we get x squared equals negative 6. All right, now square root of negative 6. We take out the negative 1. That leaves us with the positive 6. Square root of negative 1 we know is I. Square root of 6 does not break down at all. There are no perfect squares that go into that. So we just leave it as square root of 6. So x equals plus or minus I radical 6. Number 10, we subtract 12 from both sides, or 13, sorry, leaving us with x squared equals negative 12. And then we take the square root. Now, square root of negative 12, we first have to take out the negative 1, leaving us with the positive 12. 12 is not a perfect square, so we have to break it down. So I'm just going to bring down this negative 1. What is the largest perfect square that goes into 12? We should get 4. So we have the square root of negative 1, square root of 4, square root of 3. This becomes I, the next one becomes 2, and the square root of 3 stays. And when I put my answer together, we get x equals plus or minus 2I radical 3. All right, we're going to shift gears a little bit and look at some other things regarding I. And you're going to have to take I to some power and simplify that down. It'll always, when you have I to any power, you're always going to have one of 4 answers. I, negative I, 1, or negative 1. But before we get into that, let's look at and think about some exponent rules. So what if I gave you the problem x times x squared? What would you say that is? X times x squared is x cubed, or x to the 3rd power. If you think back to Algebra 1, when you're multiplying variables, you actually add the exponents. And this basically has an exponent of 1, so that's where the 1 plus 2 is 3. What about x to the 4th times x to the 5th? We were multiplying those. That would be x to the 9th, because 4 plus 5 is 9. What if I gave you this? X squared to the 5th power. It's not x to the 7th. It's going to be x to the 10th. When you have an exponent raised to another exponent, you multiply those numbers. So x to the 3rd to the 4th power is x to the 12th power. because 3 times 4 is 12. We're going to use what you know about exponents and use what you know about I for this. Now, this is something a lot of people kind of have a little trouble with, so make sure you're paying attention. So I to the first power, that's just I. And I squared, we know, is -1. Our goal with any of these types of problems where you're just simplifying I to some power is to get it down to one of these 4 options. We don't want to have any exponents left in our answer. So how can we use exponent rules to get I to the 3rd power? If we look back here, we can use the same thing, but with I instead of x. We could have I to the 1st times I squared. That is I cubed. Well, what is I to the 1st? That's just I. And I squared is -1. What is I times -1? It's -I. So you've got to be able to think about your exponent rules to come up with something, some way to simplify these. Okay. What about I to the 4th? How can you use your exponent rules? Now there's a couple of ways, but I want you to try to do it with only using these 2. That way you only have to have 2 things memorized. You don't have to memorize everything else. Just I and I squared. So there's a couple ways you could go about it. Probably the one that would come to mind to most of you would be I squared times I squared is I to the 4th. Well, I squared is -1. So -1 times -1 is what? +1. All right, let's go to I to the 5th. So we could do a few different things. But I'm going to show you kind of how you're going to do all of the same problems, all of the problems from here on out. So if you have an odd exponent, let's first just do I to the 1st power. This will be I times I to the 4th. All right. I to the 4th. Now, because we just did that one, we know that's 1. But let's pretend we didn't just do it. Let's just see how we can write I to the 4th. What if I do this? What I just wrote right here, is that I to the 4th? It is, because your exponent rules, remember, you multiply them. What is I squared? -1 squared. What is -1 squared? Remember, you have to put if you're squaring a negative, you have to put it in parentheses. If you don't, you'll get the wrong answer. So if you do -1 squared, that's +1. So I times 1 is just I. I told you this is confusing. So we're just doing lots of examples until you catch on. All right, I to the 6th. What if I write this? Is that I to the 6th? It is, because our exponent rules tell us that we would multiply the 2 and the 3. Do you know what I squared is? You know that it's -1. So I replaced the I squared with -1. Now in your calculator, do -1 in parentheses to the 3rd power. And you should get -1. All right, let's look at I to the 7th. Anytime it's odd, we're going to write just I by itself. And we're going to multiply that by I. If we're taking out one of the I's, we have 6 left over. Well, I to the 6th, I'm going to write it like this. This would be I times -1 cubed. We know that -1 cubed is -1. So I times -1 is -I. And then I to the 8th, we can do I squared to the 4th power. This would be -1 to the 4th power. Which is +1. If I were to keep going, I to the 9th, to the 10th, to the 11th, to the 12th, this pattern would continue. I, -1, -I, 1. That pattern goes on. But you're going to get some big exponents, and you're not going to want to write out that pattern. So if you just remember how to solve them, you can do it with any exponent. So when you have an odd exponent, your answer is going to be I or -I. Because we pull out an I in the beginning. So if it's odd, we pull out one of the I's. And that leaves us with I to the 34th. So we're going to pull out one I. This is only for the odd ones. And then with whatever exponent is left, we're going to write it I squared to some power. So what needs to go in that blank? needs to be 17 because 2 times 17 is what's going to give me 34. So we're always going to take, so whenever we have an even exponent now, because that 34 became an even number, we can write it I squared to some power. And we're going to fill in the blank. So I squared to the 17th power. So I squared is -1. So we replaced that. And then we're going to simplify. I times -1 equals -I. So the ones with the odd exponent, if you remember that it's either I or -I, you got a 50-50 shot, even if you have no idea how to do it. But the odd ones, the ones with the odd exponent, those are longer and more complicated. They have a few extra steps. The even exponents is basically just this. Oops. It's basically just this side. So you don't have that extra step of pulling out the I. So if we have an even exponent, it's 1 or -1. There's no reason to pull out an I because it's already even. So we can already go I squared to some power. What power does that need to be? It's going to have to be 31 because 2 times 31 gives us 62. And we know that I squared is -1. So -1 to the 31st power is -1. And that's your final answer. So if you need to pause this to catch up or to go back and look, feel free. So I'm going to give you another one just to kind of do on the side here. Simplify I to the 51st power. So pause the video, take a minute, see if you can do this one. All right, so because that was odd, we first have to take out one of the i's, leaving us with I to the 50th. And then we're going to rewrite this as I squared to the 25th power. The reason I do this is because I know what I squared is. I know that I squared is -1. So I'm using the tools that I know to get my final answer. So I squared, oh, I don't need to write that again. Let's make that a -1 to the 25th power. we get I times -1, which is -I. All right, let's go down to just a few more examples. On these, we're just multiplying numbers that have I in them. And actually, I take that back. We're just going to skip these last ones. That probably makes you happy. Just skip those. I'll make sure there's not any of those on the test. All right, so I know that this was kind of a long, complicated lesson. It's got a lot of new things in there and things that you're not used to. So you may need to go back and watch some of these examples again. Go back and watch the explanations for them because you have to know how to do these things later on.